Next shape we're talking about, guys, are rectangles. Excuse me. So rectangles are awesome because they have all the properties we've already talked about, but they also have two more. So when it says all the opposite angles are congruent, well, the reason why they're congruent is because all four angles are right angles. So all four angles are right. And I really hope you remember that a right angle is 90 degrees. On top of diagonals bisecting each other, so making their halves congruent, the diagonals themselves are congruent to each other as well. So if you know one diagonal, you know the other. Okay, so with all these properties in mind, we are going to start solving for some missing sides and angles. Question 1. I'm not even going to read the question. I'm just going to start filling in the things I know I can fill in. I know there can be a 24 here. I know there can be a 10 here. I don't know either of the diagonals yet, but what I do know, since I know that they are all right angles, I know that I have a right triangle right here. So to solve both diagonals, I know I need to do that Pythagorean theorem that we talked about last unit. A squared plus b squared equals c squared. And I know that all these angles are right. So I need to find my c, which I do not know, so I can just leave it as c. So 10 squared plus 24 squared equals c squared. Okay, 10 squared, that is 100. 24 squared is 576 equals c squared. Add those together, you should get 676. And then remember, we want the square root. So c will equal 26. So now that I know this diagonal, I know both diagonals. So erase all of this. So this whole green side is 26, which means the other one is 26. Okay, so now we can start filling things in. QR, the right side, is 10. SR, the bottom, is 24. SQ is the same thing as PR. They are both 26. And QT, so remember, they do bisect each other. So QT is half of the diagonal. So it would be 13. Number 2 is just like this one, so I'm going to leave you guys to try number 2 on your own. Don't forget your Pythagorean theorem. I'll even put it in here so you don't forget it. Okay. I am going to move on to number 3. So again, number 3, looks like in this case they're looking for all angles. So real fast, we know that the angle altogether is a 90. So the first thing I'm going to want to do is do 90 minus 27. And that should be, I believe, 63 if I'm subtracting correctly. 9, yeah. So that is 63. The nice thing about a rectangle is I have many triangles inside of it. For example, I've got this one. And this would be an isosceles because I know that the diagonals are the same measurement, right? So if I have an isosceles and the two sides are the same, the two angles at the bottom of those sides are the same. So in this case, this angle on the left is 27, even though I wrote all over it. That means the other angle will be 27. Rectangles are mirror images of each other, so if the above angles are 27, these angles will also be 27, okay? We could do the same thing on the left and right sides. We have another triangle here. And again, these are diagonal, so they are the same. So that means the angles at the bottom of these sides are also the same. So if I have 63 at the top, I have 63 at the bottom, and it's a mirror image, so I have 63s here as well. I have a feeling they're going to ask me about the angles here, so let's just go ahead and start solving for them. What we can do is, why not? Let's just pick this one. We have this triangle. Two angles are 63, so 63 and 63. Let's add those together. 3 and 3 is 6, 6 and 6 is 12. Subtract that from 180. You should get 54. If the right side's 54, the left side will be 54 because they are the same little triangle within the rectangle. And just in case, they might ask us for these angles. But I have a linear pair right there. So what I can just do is I can take 180 minus 54, and I should get 26. So if I get 26 right there, I get 26 right there. Okay, now we're going to do the tracing game. M to J to K. M, J, K. That whole angle, it's a rectangle, so I hope you remember it's 90. Right. That one was a freebie. M to J to L. So M, J, L. Well, in that angle, I see the 63 in that corner, so 63 would be my answer. Next, J, L, K. J to L to K. Well, right here, it says 63, so I will do 63 again. K to M to L. So where's K? There, K to M to L. Well, right here, I see the number 27. And lastly, M to N to L. That one is 26. Oh, I apologize, guys. I'm just realizing. Maybe 126. 180 minus 54 is 126, not just 26. What was I thinking? I apologize for that. So 126. Always check your subtraction. Make sure you didn't make any errors. Even math teachers do it. Okay, number 4, same scenario as number 3. So again, I'm going to leave you to do that. Just subtract correctly because apparently Miss Kelly can't. Use a calculator. Calculators are our friend. I'm going to go over to number 5. Number 5, they give us a couple things. D to B, so this whole diagonal is 42. So then I know if the whole thing is 42, I know each little part is 21. So if those are 21, these are 21. Okay. A to D is 26. Well, if A to D is 26, its opposite is also 26. And then D, A, E. D to A to E. So kind of like that left side of angle A is 52 degrees. I'm going to use a different color so we can differentiate between angles and sides. This is 52. Well, I know all of angle A is 90, so I'm going to do 90 minus 52 so I can figure out the other part of angle A. And that would be 60, so 38 degrees. Okay. And just like we discovered in question 3, if we know one side, we know the other's the same. If we know this side, the other's the same. So I can do a lot of copying. If I've got 52 on the top left, I know that the bottom left is also 52. Same thing with the side across from it. So I'm going to fill in those 52s. The 38s now. If I know I have a 38 here, I have a 38 right there, and I have a 38 on both bottoms. Okay, let's start answering some questions. AC, where's AC? Well, AC is right there. 21 and 21 is 42, just like that other diagonal. Next, EB. E to B, ooh, I filled it out, it's 21. BC, B to C, 26. AB, right there. Ooh, I don't know this one yet, but I do have a right triangle. So again, we have some Pythagorean theorem to do. Here's my 90 degree in the corner. The side across from it, I know because each half of that side is 21. So this whole side is 42. So 42 squared. I have a 26, and I still don't know the b squared. Okay, we will be using a calculator because these are some big numbers we're going to be getting. 26 times 26, we get 676 plus b squared equals 42 times 42, 1,764. Move our 676. We get b squared equals 1,088. And our last step to get b by itself is to get rid of that squared. So I'm going to take a square root of both sides. And b will equal approximately, it says 32.98, so I'm just going to call that 33. It's close enough. Okay. Thank goodness we have that Pythagorean theorem. So, we used orange for sides. I'll use orange. This side is 33, which means this side is 33. AB we just found was 33. Okay, now we're going to talk about some angles. Angle ADC. ADC. It's a rectangle. We're talking about that whole angle, so we are talking about 90 degrees. Next, we are talking about, excuse me, angle ABD. A to B to D. I see a 38 right there. Next is BCA. BCA. I got this arrow right here pointing, so I have 52 for that spot. And lastly, angle DEC, D to E to C. We don't have that yet, but I have two angles. I have two 38s there. So I'm going to add those 38s up. I should get 76. A triangle is always 180, so 180 minus 76 equals 104. 104 degrees. Okay, give questions 2 and 4 a try. If there's anything that did not make sense, please call me over. I'm happy to explain anything. These pictures do get pretty complex. We are filling in a lot of stuff, so please make sure you stay organized and you're labeling correctly. And again, if you are stuck, please call me over. I'm happy to help. If you get it and you got all your notes, you are ready to move on to your practice problems.